Okay, today we are going to graph cosecant and secant. We know that cosecant is the reciprocal of sine. So let's go ahead and fill in our sine key points. Sine always starts at 0. And so cosecant, if I reciprocate 0, I'm going to get undefined. Reciprocate 1, I still get 1, and then we have undefined, -1, and undefined. And wherever we have an undefined, that's going to give us an asymptote. So in the graph, when x equals 0, we're going to have a vertical asymptote, where x equals pi, and also where x equals 2 pi. So I'm going to go ahead and graph those asymptotes, and I'm going to graph the two ordered pairs that we have also. We have our vertical asymptote at 0, at pi, at 2 pi. And as I'm graphing these, I'm going to have to continue my pattern. So I'm going to look and say, how far apart are these asymptotes? How far apart are they? They are pi spaces apart. So every pi, I'm going to draw another asymptote. Pattern's going to continue forever. And then our ordered pairs, we have one at 1, 1, or I mean at pi over 2, 1. And we have an ordered pair at 3 pi over 2, -1. And then this pattern continues. I went ahead and graphed cosecant on Desmos. Oops. So you can see what it looks like. Have an idea of what it looks like up against those asymptotes. The graph is going to just get closer and closer and closer to those asymptotes. It's never going to cross them. It's never going to be equal to the asymptote. And then once you pass over the asymptote, it drops all the way down or all the way up to the other side. So we're just going to sketch that. The parts are always going to go away from each other. They're never going to go near each other. I mean, they're not going to go towards each other. They're going to go away from each other. Okay, so we have the cosecant of x graph. We're going to answer the question, what are the asymptotes? Because there's an infinitely many amount of them. There's infinite asymptotes. We're just going to give a formula that gives all of the asymptotes. So all the asymptotes are x equals, and I'm going to pick the very first one that I got out of my chart, which is this one right here. I'm going to pick the first one, that's 0. And after that, we're adding on pi, pi. The next one we're going to add on pi. So for all the asymptotes, we're going to have some number of pi's. We're going to start at 0 and add some number of pi's. And this is where this k is an integer. So if k was 1, we would have an asymptote at x equals pi. Or if k was 2, we'd have an asymptote at x equals 2 pi. k was 3, we'd have an asymptote at x equals 3 pi, and so on. So this is how you're going to write your asymptotes. Okay, next is secant. Go ahead and start with cosine. Cosine starts at 1 for our key points. And then we're going to go ahead and reciprocate those. Let 0 is undefined. That means we have some asymptotes. One of them is at x equals pi over 2. And we've got one at x equals 3 pi over 2. Go to my graph and graph those. Here's pi over 2. So I've got a vertical asymptote there, 3 pi over 2. And then we ask ourselves, how far apart are these? These are pi apart. So I'm going to continue the pattern. Drawing those asymptotes. The points I can graph 0, 1, pi, negative 1, 2 pi 1. I'm going to continue my pattern. I'll show you using Desmos what the graph should look like. Your secant looks a lot like cosecant, it's just shifted over. Or cosecant and secant at the same time, I could show you also. Maybe. There we go. You can see they're the exact same shape, they're just shifted over pi over 2 or 90 degrees, just like regular sine and regular cosine. So the graphs go away from each other, all the way up, all the way down. We don't cross over the asymptotes. I'm going to write my asymptotes knowing that they're always x equals. And the first one that I have on my graph, or on my chart, is pi over 2, so I'm going to write that first. And then from there, we are adding on an amount of pi. So any amount of pi, as long as k is an integer. That would be our asymptote formula. So one more time, we are starting with the first asymptote and figuring out how far I go from the first asymptote to the second asymptote. That is plus pi. I can do that using the graph, or I can use the table to do it. So the pi goes here, and then we have any number k. So now we're going to put transformations in that. This one is cosecant. So I'm going to use the values from example 1 as my key points. Looks like we have an A value of 3, so that's multiplying. And then we have a D value of 2, and that'll be adding. So if I take undefined and I multiply it by anything, nothing's going to change. So the undefined is still going to be undefined. Undefined, still undefined. Undefined, still undefined. So 3 plus 2 is 5, negative 3 plus 2 is negative 1. We do not have a B or a C value, so now I'm going to graph this column, and this column is my X and my Y. Every place that I see an undefined, that's an asymptote. So I've got an asymptote at X equals 0. I've got an asymptote at X equals pi. Asymptote at X equals 2 pi. And then continue the pattern. And while I'm graphing those, I'm thinking about how far apart these asymptotes are. From here to here. There we go. From there to there, we've got a spacing of pi. That's how far apart my asymptotes are. See, we also have our ordered pairs. So pi over 2 is 5. At 3 pi over 2, it's negative 3. And these are going to go away from each other. So I'm going to follow my pattern now. And then we're going to write our asymptotes. Asymptotes x equals. The first one that I have in my chart is 0. And I'm going to add on pi each time, so some number multiplied by pi. I didn't write 0 plus because you don't have to write 0. That's why I did not write it. K is an integer. All right, next one. This is so much fun. You can tell you're having fun. Secant. We're going to start with our key points from example 2 for secant, and that was 1, and then undefined, and then negative 1, undefined, and 1. See, do we have an A value? We do. We have a negative 2 for our A value. So multiply everything by negative 2. Do we have a D value? We do not, so I do not need that column. Do we have a B value? The B value would be right there after secant before the parentheses, so B is 1. I don't really have to do anything. I mean, I can divide by 1, but it's not going to change any of those X values. So I don't really need that column. We do have a C value. We have a C value of pi. Remember, we always do the opposite. It says minus pi. I'm going to add pi for the C value. So we're going to take this 0 and we're going to add pi on. So pi. We're going to take pi over 2 and we're going to add pi on. And I've been doing this lately a lot, so I'm kind of starting to memorize that pi plus pi over 2 is 3 pi over 2. If I do not have that memorized, then we're going to have to add fractions. And I'll do that on one of them so you can see how to do it. See, pi plus pi is 2 pi. And then 3 pi over 2, that one I'll pretend I don't know how to figure it out by hand, so I'll just do 3 pi over 2 plus pi. But I have to have common denominators, so I'm going to make pi the same thing as 2 pi over 2. So that's going to give me 5 pi over 2. And then we have 2 pi plus pi, so 3 pi. Looking for vertical asymptotes, I've got a vertical asymptote at x equals, and I'm going to look all the way over to the left, 3 pi over 2. And then right here we've got x equals, all the way to the left I've got 5 pi over 2. So my graph 3 pi over 2 is here. I've got a vertical asymptote, and then 5 pi over 2, right there. You notice that those are 2 spaces on my graph, so that is a total of pi apart. Go ahead and put the rest of the asymptotes in. And then graph my points. We got pi negative 2. And we've got 2 pi 2. Three pi is negative 2. And these go away from each other. Do not cross over the asymptotes, even though that one was kind of sloppy. Follow the pattern. I could probably squeeze this last one out here. Why not? There we go. And so our asymptotes, x equals, I'm going to start with 3 pi over 2. And I'm going to add on k pi, some value, some number of pi's, where k is an integer. It would totally be fine to also start at the first positive one from your graph. You don't have to start at the one from your table. You can start at pi over 2. Either of these would be acceptable answers. I'm just using the table to do it, but you could use the graph to do it. Either of these would be acceptable. All right, last one. We've got secant. I'm going to use my key points for secant. 1, undefined, negative 1, undefined, and 1. A value, the amplitude, the A value, we do not have one other than 1. So I can, if I want to, multiply by 1, but it's not going to change any of the values. D value, I do have a subtract 1 there. So we'll have 0, negative 2, 0, and then these are still undefined. Then I'm looking for a B value, and I'm looking for a value here, but the problem is there isn't a value there, and there's one here instead, and that can't be there. Inside the parentheses, it can only be like x minus c, where the b is on the outside, so we're going to have to factor that out. Factor out. Move this out of my way for a moment. When I factor out a half, we're using division. So when I factor out a half, I have to divide by a half. And dividing by a half is the same as multiplying by 2. So when I go to do this term, the c term, I need to multiply that by 2. So if you have to factor out the b value, you've got to make sure that your c value is also changing. That would be a place where I see mistakes happen often. So our b value is 1/2. But we always do what's opposite over here on the chart. So I'm going to multiply by not 1/2, I'm going to multiply by 2. And then our c value is pi over 4. And it's positive, so over here I'm going to do minus pi over 4. And if you need to do the fractions by hand, like 2 pi minus pi over 4, that would be the same thing as 8 pi over 4 minus pi over 4, 7 pi over 4. If you need to do fractions by hand, please do that. You might notice a pattern. These are going up by 4 pi over 4 each time. So then I can continue my pattern, 11 pi over 4 and 15 pi over 4. Oops. What happened there? There we go. Oh my gosh, sorry. All right, then filling out the period, we had a formula last class. Same formula applies. We do 2 pi over the b. So if I take 2 pi and I divide it by my 1/2, dividing by half, same thing as multiplying by 2. So my period is 4 pi. The phase shift, that would be the C. What is that doing? It's moving it left, pi over 4. The vertical shift, that would be my D value, and we are going down 1. The domain and the range, I'm going to come back to those in just a moment. And the asymptotes, we'll go ahead and graph it first before we fill out those last 3. So let's see, my asymptotes. I've got one at x equals 3 pi over 4. Got another one at x equals 11 pi over 4. I'm not sure where 11 pi over 4 is. I know that it is just pi over 4 less than 3 pi. So if I find 3 pi in my graph and I go pi over 4 less, that's one of my asymptotes. The other one was at 3 pi over 4, which is just half of those blocks smaller than pi. There's 2 of my asymptotes. I know 2 spaces on this table or on this graph. 2 spaces, 1, 2 is pi. So these are 1, 2, 3, 4 spaces apart. These are 2 pi apart. So I can go this way, 1, 2, 3, and then on the 4th space, that's going to be another asymptote. I can go the other way, kind of getting off the graph. 1, 2, 3, and it's like way out there. See, where else do we have points? We have points at negative pi over 4, 0. Here. We've got 7 pi over 4, negative 2. And then 15 pi over 4, which is just shy of 4 pi, 0. And these go away from each other, so that's how I figure out which one goes up and which one goes down. So they're going away from each other. So our domain, actually, let's do our asymptotes are going to be x equals, and I'm going to start with the first one in my chart, which is 3 pi over 4. And I'm going to add on 2 pi each time. So there's a number of them that I could add on. I'm going to say 2k pi, where k is an integer. Now my domain is everything except for the asymptotes. So my domain, I'm going to take what I wrote for asymptotes and I'm going to write x does not equal 3 pi over 4 plus 2k pi, where k is an integer. We could write our domain in interval notation, but it would be very, very messy. So we're just going to write it in set notation, the way I wrote it right there. And then the range, it goes up forever and down forever. So our range is going to be negative infinity. Oh, it does not go up forever and down forever. Just kidding. It goes all the way up and all the way down, but there is a portion in the graph where the range, where the y values do not happen. be in between this little section right here. There's no y values in here. There's none of the graph in there. So interval notation for the y values, we're going to have negative infinity all the way up to -2. And it can equal -2. Then we're going to union that with the next value it goes to is 0, and it can equal 0. And it's going to go all the way to positive infinity. So that would be our range. Hey, feel free to watch this video as much as you need. Come with questions tomorrow if you have any. The assignment is worksheet 4.6, number 1. Enjoy.